You have to read this problem pretty carefully, and you have to also know what a 10-year CD is. So a 10-year, this is a certificate of deposit is what CD stands for. It's not a musical CD. It's a 10-year certificate of deposit. So what happens with those is you put a bunch of money, well, hopefully a bunch, into the bank, into this certificate of deposit, and there's a penalty if you withdraw it early. So if this is a 10-year CD, it's supposed to be in there for 10 years. So it's kind of like you're guaranteeing the bank, I'm going to put this much money into you for 10 years, so they can borrow against it. And so if you pull it out early, they don't give you as much of a benefit as if you leave it in there for the 10 years. And at the end of the 10 years, if you pull it out, you get a bunch of interest, and so that money has grown a substantial amount, is the idea. It requires a minimum of $2,500, but you get this much interest compounded daily. And even though this is the minimum required to open it, you decide to put away this much. So in our problem, this number is not important whatsoever. That's like it's just information that you need to filter out that you don't need, because just because that's the minimum doesn't mean it has anything to do with what we chose to do. We chose to put in $10,000. Wouldn't that be nice, right? How much money will be in the account by the time you can withdraw the penalty? Without penalty. That's 10 years because it's a 10-year CD. So we are going to use our formula, y equals a 1 plus r over n to the nt. The initial amount is going to be 10,000. 1 plus the rate, if you move this decimal place 2 places, is 0.0245, and we are compounding daily. That means we are doing it 365 times in that year, and so we're going to raise it to the 365 times t, but if we know how long we need it to put in there, we need it to be in there for 10 years, then t is going to be 10 years. So because I'm doing it daily, I'm putting n is equal to 365. N is the number of times you compound each year. So now I just need to put all of this into my calculator, and you need to be really careful with your parentheses. I would not put it all in at once. I'm gonna calculate this first, get a number there, and then I'll finish the rest of it from there. So take your calculator, and I'm just going to do 1 plus 0.0245 over 365. So it's about that number. Now I'm going to take this number, and following order of operations, I'm not going to multiply it yet. I'm going to raise it to this exponent. So I'm going to raise this to the 365 times 10, and now I can multiply it by my 10,000. So I should have $12,776.11 if you round that properly. So basically you earned $2,776.11 for doing nothing except letting your money sit. Second question, how long would it take for the money in the account to reach 30,000? So the initial amount is still 10,000, but now my y value, what I'm getting, what I want out of it, is going to be 30,000, and t is going to be my variable here. So 30,000 equals 10,000, 1 plus 0.0245 over 365 raised to the 365t. I have to solve this a little bit differently. I can go ahead and compute this again if I want and get a decimal there, which you can still see from what I had in here is this 1.000067. But my first step here is going to be divide by 10,000. So I'm going to get 3 equals, I'm going to go ahead and put this number in, 1.000067, raised to the 365t. So now that my variable is in the exponent, I need to use logarithms to help me solve this. So I can do log base this of this is going to equal this. So log base 1.000067 of 3 equals 365t. So again, using the change of base, I can do log base 10 of 3 over log base 10 of this. So I can use my calculator to figure out what that fraction is going to be. So it's going to be the log of 3 over the log of 1.000067, and then I'm going to divide by 365. So t equals 44.9. And remember that that is in years. So it's basically going to take 45 years for this amount of money that you started with to triple to $3,000 or to $30,000. All right, last part, part C. If the account was compounded continuously, how much more money would you have after the 10 years? So we're not going back to part B, we're going back to part A. So when we compounded it daily, my answer from part A was 12,776.11. So we're asked how much more money would you have. So once we get the answer to this problem, we're going to subtract this because we want to know how much more we would have if we compounded continuously. Compounding continuously has a different formula. It is y equals PE to the RT. E being that natural logarithm, or that natural number, E is about 2.72, but you also have this button on your calculator that does e to the x. So we're still starting with the $10,000 as my initial principal, and then I'm doing e, and then the rate is still 0.0245, and we are asked about 10 years, so I'm going to put 10 right here. So I can put this straight into my calculator. I'll show you that right here. So the E button is down here, right above your LN. It's right here in yellow on mine, so I'm going to have to hit the second button first. So I'm going to do second, and then that E, and I'm going, oh, let me put in the 10,000 first. And then e to the 0.0245 times 10. So that, compounding continuously, gives me this much money when I'm doing it continuously. And when I was doing it daily, I had this much money. And so how much more money is this than this? It is 10 cents. That should make sense because compounding continuously is better, but it's harder to get much better than compounding it every day. So there's not a big difference between that. If we were compounding quarterly and only doing it 4 times a year versus continuously, there would be a much bigger difference there.